the review answers that I sent you? Anyone have questions on the problems that I send you answers to?
Can we go over 10D?
Sure. Well, let me just get it. 10B. Let's see what is 10B.
10D, the last section.
D, you said. Are you saying, okay. This, the range?
Yeah.
Okay. What happened for this one is, I looked at the slope field, right? And the initial point that they give me is, the initial point given here is at, no, I'm sorry, it's f of 0 equal 8, right? That means the graph of the function is going by this dot. Yes? The graph is passing by 0, 8, which is this dot. If you follow the tick marks, can you tell that this line here is most probably asymptote? Whenever you see a horizontal line like that, it is an asymptote to your graph. So the graph is going from up like that, going like this with this asymptote. So the graph is, the range of this graph will be 6 raised to infinity, from 6 to infinity. If the initial condition was, for example, 0, 2, you would be going from down here like that, right, with the 6 asymptote again, and I think there is another horizontal line on the x-axis, so you're going on the other side with the horizontal line to the x-axis like that. So that would be, what do you call it? What logistic equation? Remember that logistic equation that we went over once? Anybody remember that?
No.
No? Okay. Logistic equation is something that look like this. Let me open a new new document. I'm going to type in this here. Look, logistic equation is the equation of the form of this: k y times L minus y. What is that? K is constant, L is constant. Basically, you don't see x in that differential equation, right? Second, this is constant times y. This is the limit minus y again. In this case, this is what we call logistic equation. Okay? Logistic equation is the equation that we write to represent population growth or decay that's different. Like there's two models of population growth and decay. One is the exponential, e to the x, that's one, which basically the graph is going from down here and up forever, right? Or if it's decay, it's going from up and going down like this forever. Correct? That's e to the x or e to negative x. This is the exponential function. The other kind of function is this. It's logistic. What's a logistic? It's basically the function have a limit line here that this is asymptote to the function. horizontal line that's asymptote to the function. That line is L. Where is L appear in the equation? L is right there. The number minus y. Yes? Okay. With this, the graph will go from down, increase, 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 as if exponential equation, and then taper down to have the same limit as asymptote. Never exceed that. This is called logistic equation. Okay? So basically we say the rate of growth of the population, right, very directly as or proportionate to the population itself. Why is the population itself? And a limit minus the population. That's what the logistic differential equation should look like. So if you look at this, what would be that limit? 6. What is the constant K? 1/8, right? So if this is a population in thousands of, like, for example, number of deers in a forest, we say the maximum number of deers that could be in that place is 6,000. No more than that. We call this carrying capacity. If you learn anything in biology, I think they call it carrying capacity. How much life this forest can sustain. The amount of food will not be enough for more than 6,000 to live in there, right? Anyway, so this is what we call logistic equation. What else about logistic equation that you can answer? Yes, this will increase. Look at this. Increase. The rate of increase is going faster and faster and faster as you go until you reach half of that L. Half L. And then after that, it goes down. The rate goes down, but the function itself keeps increasing still. But the rate is going down. Yes? And that's what I know about logistic equation. Would you like to see how they solve it?
Yeah.
So
Okay.
How do you find the range with this?
I'm sorry?
So how do you find the range?
How you find the range?
Yeah.
Okay. See, logistic equation is a general equation. If it represents population, or like I said, it's going to be this one, right?
Yeah.
But the one that they gave us, they said it is passing by this point on top. On top, the graph is going like this and down to be that. So there are two different equations now. The one, if you pass by a number that is greater than L, the graph will go from infinity going down to be with an asymptote at L.
Yeah.
But if the point that is given is below L, then the logistic equation will increase, and then the rate of it will increase, and then the rate of increase will go down until it become asymptote with the asymptote L,
So
getting closer to that L.
they give you the point above the asymptote, you know, it goes from infinity all the way down to the asymptote.
Yes.
Got it.
Yes.
But Mr. Ayat,
Yes.
for the question, it says that the range is from t greater than or equal to 0, but doesn't it only go to infinity for t less than 0? So wouldn't the range?
I'm sorry. Hold on 1 second. For this problem, what does it say?
It says to find the range for t greater than or equal to 0.
For t greater than or equal to 0. Yes, this is the time is greater than or equal to 0. Oh, you're absolutely right. I'm very sorry, guys. From 0 on, they don't want all of it. Then I made a mistake in my answer. It's not all of it. It's not for any t. I did not read that part, to tell you the truth. I was just rushing at the end of the day to make answers for you and the A, B, and send it to you. It says range, so I looked at the range. I did not look at the end of it. You're absolutely 100% correct when it says t greater than 0. That means I'm looking only from 0 on, from y-axis on. So from y-axis is 8 on is going with the asymptote 6. So it's between 6 and 8. The range would be 6 to 8. And 8 is included while 6 is not. It will look like that. Insert equations where we have a bracket. Where is the bracket? 6, comma, 8, and parentheses.
Isn't it the other way
No,
around?
no. It's the other way. I'm dyslexic. Okay. So bracket here and parentheses there because the asymptote will never reach, right? We'll get closer to it, but never be on it. And that's what it is, 6 to 8. You're right. It's only from t greater than 0, not all of it. Any other question?
You're over 12.
You finished the 12?
Yeah,
Okay.
I did it. I tried to do it.
Which part of it or all of it?
You start with A.
Huh?
It's 12A.
Okay. Let's see. It says let h of x equal to this for x greater than or equal to 0. And h of x is the length of the graph of g from t equals 0 to t equal x. Euler's method starts at x equals 0 with 2 steps of equal size to approximate each of 4. Okay. That's weird. Did they give us value for that?
Well,
Each?
if you plug in 0, then you would get 0 because it's from 0
Ah, from 0 to 0, you're right. If you plug in the 0, you get 0. Right. So this is my function, and I would like to apply Euler's method twice, 2 steps, to find the h of 4. That means the delta x in this case would be a 2, right? So here's my thing here. I would say first, we're going to insert an equation and we say f of b equal f prime of a times delta x plus f of a, right? Okay, let's go. I'm copying the formula and I'm applying it twice, right? So first, what f of what that I'm getting here? F of 2, while the a is 0. Now we can put our numbers in. The numbers are f prime of 0 is the derivative of this at 0, right? The derivative of it at 0. Remember, the derivative of an integral is to replace the x with the t, right?
Yeah.
Second fundamental theorem of calculus says the derivative of an integral from a number, from any number to x, is to replace t with x. So the answer is square root of 1 plus 4x squared. Put the x as 0 because that's what we're finding. F a prime of 0, you get square root of 1. That means this is 1. Make sense? And delta x is the 2. And f of 0, we said it is 0. So it is equal to 2. Yes?
Yeah.
Now next time. Next time we copy exactly the same thing again. And our point now is at 2. The starting point is 2. We're finding f of 4. And the a is the 2. The middle point is what we put in the second time. So again, we're going to copy that and put our numbers in it. F prime of 2 is the same what we just said, which is the square root of that. Replace the t with the 2. What would that be now? That would be 16? Sorry?
Oh, the whole thing would be square root of 17.
Right, square root of 17 is the number here. So I'm square root of 17 times delta x was the 2 and f of 2 was whatever we found before, which was that 2 here. And that's it. So the answer is 2 root 17 plus 2. 2 root 17 plus 2. If you wish to write the 2 first, 2 plus 2 root 17, that's how most people write it.
For
So
12a,
what?
for 12a, how do you take the derivative of the absolute value function?
Where's the absolute value function?
12a.
Oh, which one we doing now?
12c. I had problem 12c
Why
too.
did I start C? Why you started with C though?
I wanted to see C as well.
No, it's very strange. How did I skip A and B?
I guess you didn't like them.
I'm just going out of my mind. It's okay. Because somebody talked about it? Maybe. I don't know. Anyway, part A. Find the expression for g of x and g double prime of x. Let's do that. Did we learn how to get derivative of absolute value? No. Did we learn how to get integral of absolute value? No. So how would I be able to do that? By switching this function and rewriting it
As 2.
as a piecewise function. Piecewise function. First of all, let's learn something simple about absolute value. If I say absolute value of 5, what's my answer? 5. What that means? If you put a positive number in the absolute value, it stays the same. Make sense? Now, what's the absolute value of -3? It's positive 3. That means we take in the negative and switch it to positive. Correct? Great. So in order to rewrite this as a piecewise function, we're going to do the following. Here's the sign for piecewise. Where is it? This of. First, we say 2x will stay 2x if x is what? If x is positive. If x is positive, this absolute value will do nothing and we'll leave it as it is. Is that true? Yes. Now, what if x is negative value? What happened? It will switch it to positive. How do you take a negative value and switch it to positive? By multiplying it times a negative number. Right? And that will be work. This sign would work for x greater than 0. Notice
Less than.
What?
Less than 0.
Oh, I meant less. I meant less than 0. Now, this here is a piecewise function. I always put the equal to because if this will equal to 0, the square root will be still a 0, so it works for even equal to 0. This one is working when you have a negative value inside. We switch it to positive. So if, yes, sir.
Could both be or equal to?
No, you can't have both equal because that will make it not a function.
Okay, got it.
Okay. So now this. You want to get a second derivative. Let's get a derivative of that. That's what we do. We get a derivative of what we have. What's the derivative of this side? 2. 2x, right? It's a 2. What's the derivative of the other one? -2. Right?
Yeah.
That's it. But there is one single mistake happen here. The equal sign. The equal sign is very important to delete it. Why? Why I should delete that equal sign? Because if you remember the graph of the absolute value, it has a cusp, V shape with a cusp at 0. Right? And because it has a cusp at 0, you cannot say the derivative equal to 2 at 0. The derivative is undefined at 0. So that's what you have to be careful with. Is that okay now?
You also have to find the integral, right?
I'm going to.
Okay.
To find the function itself, you need the integral of that.
Okay.
Okay. So here it is. Let's find the integral. I can say now that the g itself is the integral of each one separately. 1 second. What am I doing? Okay. It's this side. I'm going to insert an integral sign here, right? And dx. An integral sign there with the dx again. So I'm getting an integral of each one separately, each one by itself. That's the point. Okay? Plus dt, I'm sorry, dx and dx. Okay. Now, what's the integral of this? X squared plus c. This is the kind that's plus c, by the way. So x squared plus c. And that one?
Negative x squared plus c.
Negative x squared plus c. Now, how you get the c? Right here. It says g of 0 equals 0. So if you put a 0, you're supposed to get 0. That means the c is 0. And this one also, the c is 0. I forgot to erase the integral sign. So that's my answer now for the integral one. Yes?
Mr. Ayad,
Yes.
for this one, you would keep the equal sign,
You
right?
would keep the equal sign. Why? Because the integral would work on a cusp. The integral works on a cusp. There is an area you can get around the cusp, right? It's not going to be a big deal, but you cannot get a slope of a tangent line at a cusp. And that's what it is. Any question? Next. Part B says find the x coordinate if any of each point of inflection on the function. Okay. To get the, what do you call it? Point of inflection, don't you need to find a second derivative? Right?
We found the second derivative.
I'm sorry?
We found the second derivative.
Oh, we have it already?
Yeah, because it gives you the first derivative, so that's the negative 2 to
so this was, I forgot to make it a second then.
Yeah.
Okay, so I have the second derivative, it equal to this and that, and it's not defined at 0. So when the second derivative equals 0, never, right? When it's undefined, at 0. So the only point that is suspect for being inflection is 0, correct? Is the second derivative positive or negative before, after? This is after. After is positive. Before, the second derivative is negative. So that means there is a point of inflection at 0. Right? By the way, if you graph this, what would it look like? It's a piecewise function divided at 0. On the right side of the curve, it's x squared, right? On the left side here, it is negative x squared. It's obvious to me that's concave up here, right? And concave down there. That's the function g, which means this here is a point of inflection at 0.
So what would be like the scientific way to respond to the question?
That's what I just mentioned a minute ago. I said g double prime is undefined at 0. The g double prime is positive for x greater than 0 and negative for x less than 0. That means there is a change in sign, change in concavity, right? Around the point 0, which makes it a point of inflection.
Okay.
All right. What else? So we did we did A, we did B,
Yeah.
right? And we did C already. What are left? D?
Yeah.
Okay. D is the integral from pi over 2 to pi of g prime of x times cosine. That means now they want us to do something different. What is that question
UDV.
about?
Is it UDV?
Exactly. They want to test you for UDV, so they inserted that part for you to use UDV. Okay. Which part would I call the U? Which part would be the DV?
G prime is U.
Okay. G prime. By the way, could I substitute G prime with something? I'm not going to substitute with a piecewise function, but can I substitute it with something from this equation? This is the G prime. I'm copying it. I'm putting it here so everybody can look at it and say, would I be able to substitute this in there?
Because it's from pi over 2 to pi, that means it's positive. So you use the one that's
Exactly. That means I can use this. This can be replaced with the 2x. No problem, right? And now it's a simple UDV problem now. So we're going to say let U equal to x, right? Du will equal to dx. What else we have? dv equal to cosine, cosine x dx, right? We have to put dx there, while v is, what's the integral of that? Sine x?
Mr. Ayad,
Yes, sir.
I think you forgot the 2 for U.
No, I did not forget anything. 2 is constant, can be taken outside, and I intend to take it outside.
Oh, okay.
Okay. Why would I want to keep it? Here it is. This is the 2, and it's multiplied times whatever answer I got. So equal to, here's the 2, and here's the answer that I got. The answer that I got is uv, right? uv, which is x sine of x, right? Minus the integral from what to what? You know what? I don't have to do it this way. I'm going to do it that way. I'm going to say the integral, this kind of integral of v du sine x dvu is gx, and then on the outside I can say I am evaluating this now with pi over 2 to pi, right?
Yeah.
That's it. So it equal to let's get the answer for that first. Integral of sine is negative cosine, so it's a plus cosine x. Now just substitute the values in. What would be, that would be a pi sine pi, right? Pi, sine of pi,
Mr. Ayad,
yes.
why are you plugging it in for the first part? I thought you'd only plug it in for the second part.
What do you mean second part?
Because the second part's the one with the integral, right?
No, sir. No, that's why I did it this way, because the limit here goes on the original one. The answer for the original one is the whole thing. Both are the answer to the original one, not just part and the other part stay x.
Oh, okay.
Okay. So again, pi. That's a good question. That's a very good question. Then minus, and I'm going to put now the pi over 2. So I'm copying that and put it here, and a parenthesis around it. And every pi that I have, I'm going to make it over 2. Done? Now we, once you, I'm sorry, 1 second. Once you do that, you don't leave the limit because you already put whatever limit there was. And it equal 2, and it said 2, and a time a bracket now. Did I copy that? Copy that. Put it here, and let's put the numbers. What's the sine of pi? 0, right? What's the cosine of pi? -1. Pi over 2 times sine of pi over 2. That's a 1. And cosine of pi over 2, that is a 0, right? So what's my answer at the end? My answer is -1 minus pi over 2 and times 2. That means 2. That means 2 minus pi. Is it? No, -2 minus pi. Did I do everything right? -2 minus pi. I hope so. Okay. And that's it. That's the end of it. Okay. So that's it for this worksheet. Anybody who need anything at all from this worksheet?
Could we go over 11D?
11D. Oh, that's a good question. 11 is a good question. G. Forget D. Is this the Lagrange error? Lagrange error is not on the test. But did you understand this? It says you want to find out if f of 2 is relative max and min.
Oh no, I was kind of confused about this because I think it had something to do with this.
Put your mouth to the speaker so I can hear you.
Yeah, could we go over this one? Because I remember you said something about you could only use the equation to evaluate at a point.
Yes. So this here, they said it's a polynomial that we're using to approximate a function, the function f, right?
Yeah.
So that t of x is the polynomial that to approximate that. What that means this will equal the actual function f if you keep writing it forever, correct? Since we are writing part of it only, whatever we get is approximation, unless you find f of 2. Why f of 2? Because 2 is my center. And if 2 is my center, I can evaluate because all terms will become a 0 all the way to infinity plus the first term 7. Yes? Okay. Find the f of 2. We got that 7, right? and f of double prime. So let's get f double prime first. I'm getting the first derivative, which is that would be 18, and times the parentheses without exponent, and this would be a 9, and times this without no, with the exponent 2. Is that the first derivative? Yes. Next derivative. No, that's wrong. First derivative, and nobody talk. Derivative of 7 is 0. That's the first derivative. Right? Right. Second derivative is, what's the derivative of that, which is negative 18 times the parentheses? Is negative 18. Then 2 times 9 is 18, and it's no exponent. Is that right? That's right. So this here is whatever they asked me to get. So what's f of 2? 7, because all that would be a 0, and the answer is 7. And this one, what is f for double prime of 2? Is negative 18, because that also is 0. 2 minus 2. Is there enough information given to determine f has a critical number at 2? If not, explain why not. If so, determine if it's maximum or neither. Yes, there is enough information to say that at 2 there's a critical number. Why? Because if you put a 2 here, you're going to get 0 for the first derivative. And that is a exact value of the second derivative, of the first derivative. Right? We said when you evaluate with the center, you get exact value. So this is an exact value, which is 0. Makes 2 a critical number. Now the second derivative equal to negative 18, which is negative value. That makes it second derivative test maximum. So that's a maximum. Yes, I can. Now, part C. Use t of x to find the approximation for f of 0. That's not bad. Just put a 0 and evaluate, right? Is there enough information given to determine whether f has a critical point at x equals 0? If not, explain why not. If so, determine whether f of 0 is a max, min, or neither. By the way, if you get here and you put 0 for the derivative, can you tell me what's my answer? If I put a 0 here, somebody please help me with the calculator. Huh?
You get 0.
You get 0, right? And if you put 0 here in the second one, what would you get now? You get positive. Yes? You would get a positive answer. This is 18, by the way, not 8. Not 81. That's dyslexic. Okay. So basically, if you put a 0 here, you're going to get a positive answer, which indicate that you have a relative minimum. If you say that, you're wrong. Why? Because whatever we got is approximation. Yes, I got a 0 when I put the number 0 in the first derivative, but what if the rest of the terms that's supposed to be there, right, will add up to another number? That means you cannot guarantee that 0 is a critical number. Do you understand that? What if you add the third term and you get 5? So the answer for the derivative is a 5, not a 0, which makes it not a critical number. So you never be able to find out max and min from, unless the point is the center. Yes? Unless the point is the center, you cannot do anything else. When it comes to Lagrange here, I'm not interested because they said it's not going to be on the test.
Mr. Ayad.
Yes, sir.
So basically, if you have a Taylor polynomial and you want to find whether or not there's a relative max or min, it needs to be at the point, and you use the second
At the
derivative
center.
test.
Yep, at the center. If it's at the center, find the first derivative, evaluate it, and make sure it's a 0 before you proceed. That makes it critical number. Then find the second derivative and evaluate it. If positive, say minimum. If negative, say maximum. If it's not at center, that means they are trying to fool me. And I would say what we get from the derivative or the second derivative is only approximation. And we cannot determine the actual value of the derivative. So we cannot tell if it's a critical number or not.
Okay.
Okay. So we're done with that. One thing I want to talk about before I let you go is this. Again, these are what's on the test. That's what they say on the test from their own curriculum. So I'm leaving this here. I'm opening the curriculum here and go over that chapter 10 to see what's on from this chapter. 10.2. What is that? Geometric series. So, because this is very limited stuff that could be from chapter 9 in our book, 10 in theirs. Yes? That means you could see it tomorrow, right? As a BC, you might see this. Working with geometric series. I can add geometric series if R is less than 1. If the absolute value of R less than 1. If it's negative or positive, it doesn't matter, right? But if R is less than 1. And you should have a piece of paper with the sum written on it. What's the sum? It's A sub 1 divided by 1 minus R. So if you're not memorizing this already, you need to have it in front of you in case if you get geometric series, you can add it. I don't think this is hard. 2, 10.5. So they jump over all this stuff and they went to 10.5. 10.5 says harmonic and P series. What do we know what is harmonic? Harmonic is the one that look like 1 over and the bottom is counting numbers, 1 over n. So n could be 1, then 2, then 3, then 4, then 5, right? So it's 1 over counting numbers. That's harmonic. By the way, if you see this, I consider this still harmonic. Okay? It's like counting by 2s or counting by 3s, whatever the coefficient of n would be. Yes? So this is still, I count it as harmonic. Comparison test, if you remember, you can compare it to 1 over n, which is harmonic, which makes it divergent. What do we know about harmonic? Harmonic is divergent function, series, right? We all know that. Now, if you put a sigma on that, and then if this was harmonic, but alternating, I'm trying to make it alternating, like that, that's alternating, that means it is convergent now. So what do we know about harmonic alternating? Convergent series. Yes?
Would it be absolutely convergent or
No. Which we said the positive one is divergent.
Yeah.
And if the positive one is divergent, we call this conditionally convergent.
So would we first show how like
If you want to show, hold on a second now. If they say, is this convergent or divergent about alternating series. Alternating. Yes? You have to show two things. One is not enough. Talking about it is not enough. Showing, what do I have to show? I have to show that the limit of an, the limit of whatever written here, equals 0 as n approach infinity. So that's what I need to show. Yes?
Mm-hmm.
What else do I need to show? I need to show that the absolute value of it is decreasing. I'm getting half, then a third, then a fourth, then a fifth. That's decreasing. So you have to mention two things, please, to get your credit for this kind of problem, which is alternating, which is very much possibly on your test. You would say the limit has to equal to 0. You have to show that. If the limit something that you have to get, you have to get. And then you have to get also that it is decreasing for you to prove that it is. Okay.
Can we do one problem like that?
Okay. I'm going to make one harder so we can actually do more work to it. Yes?
Yeah.
God, I hate this. Okay, here it is. I'm going to put n raised to 2. And I'm going to put factorial on that one. Here's the series that we want to test. If it's conditionally or absolutely conversion. Yes? So we're going to say, first of all, if you test this, what you will find? The limit. So let's get that limit. What would I write first if I write the limit?
So the limit as n approaches infinity equals 0.
Raise your voice, please.
The limit as n approaches infinity equals 0.
Right. So I have to write it. I'm not just gonna talk about it because some of you just say stuff without actually telling me what they're doing. It's a limit as n approach infinity of that an equals 0. Does it equal 0, guys?
Yeah, because factorial increases fast.
Because n squared increase much less than the factorial. Factorial increase much faster. And by the way, I don't even need to involve the negative in it. I don't need to involve the negative at all in what I'm doing. Yes? Now we're going to test the absolute value. How to test the absolute value? First, eliminate the negative part of it. This is what happened when you eliminate the negative part of it, correct? This, this is what we call a sub n, right? Since it's a sub, here it is. So nobody was thinking anything. N, right? This is the term number n. Now I want to write the term number n plus 1. That's the best method, by the way, for this kind.
Ratio
test. The ratio test is there. It's in the curriculum for the testing. Plus 1. And then instead of n, what do? We replace with n plus 1. Each n become n plus 1. And each n become n plus 1. That's what we do for the ratio test. Right? Right. Mm-hmm. Now what do we say? We say we want to find the limit as of a sub n. The positive part only, we never include the negative. divided by a sub n. Right? And normally I would, okay, I can't. Okay. So what do we do next?
Write it as multiplication.
We try to, by the way, it does not equal to 0.
Wouldn't it be less than 1?
I'm sorry? We need the answer to be less than 1. So I'm not going to write that it is less than 1.
Mm.
When would I write it less than 1? When it involves x as a variable. So I make it less than 1 to find the x that makes it less than 1. But this has no x's in it, and we just want to find out if it is if it's converges or diverges. Yes?
Triad.
So we are testing to see if the answer is less than 1 or not.
Mr.
So
Arthur,
what?
when you set the x less to 1, isn't that only for the interval of convergence, which isn't on the test, right?
You wanted to do the integral test?
No, you were saying about setting the x less to 1. Don't you only use that for the interval test when you're testing the interval of convergence?
No, not the integral. I'm setting it less than 1 if the series that they write involve x.
Okay.
Like the one that we learned for Taylor-Maclaurin series, the one that for Taylor-Maclaurin series that we were just working on, I can test it if it is for what numbers of x. Remember the table that you copied for series like Taylor-Maclaurin?
Yeah.
Doesn't next to each one of them says when it converges between what number and what number?
Yeah, that's what I said, the interval of convergence.
Yeah, that's to find the interval of convergence of a series like that.
Okay.
So there's some values of x that makes it convergent, some values makes it not convergent.
Wait, so how does that relate to this problem?
It's not related to this problem.
Oh, okay.
Just people ask me why you don't make it less than 0. This one, I'm not going to make it less than 0. It should become either less than 0 by itself or greater than 0 by itself. If it's less than 0, I would say
It's convergent.
converges. More than 0, I would say diverges. Equal to 0, I would say test failed. And I have to use another method.
Mm.
Yes?
Yeah.
Yes. So what we do here, we're going to make this. Did I do it? Yes. No, I did not. Okay. I'm going to flip now, right? And make it times. Times. And take that and flip it. The n square goes on the bottom. The absolute value goes on top. And that's how flipping goes. Then what's my next step?
You can rewrite stuff. So like n+1 times n factorial.
Make each kind together. Separate them. The parentheses squared over the n squared, the factorial 1 over the factorial 1. I put them together to make it simpler for me to simplify. So each fraction, I create fractions, and each fraction contain same kind. This here, same kind. This there, same kind. That makes it very simple to simplify. Yes?
Yeah.
Please do that, and you're allowed to do that as long as any number in the numerator stays in the numerator. Any number denominator stays denominator. You don't flip anything wrong. We only flip to switch the divide into times, right? And then what? And then equal to. Let's simplify. This one, what would be the limit? Is since this is the same degree, it's a leading coefficient times a leading coefficient.
1.
1. One times, what would that be? That would be,
Over n factorial.
it's
n+1.
you simplified that as n plus 1. You simplified that as n plus 1 times n times n factorial, and then the n factorial cancel. So what's left is 1 over n plus 1, right? Now substitute the n with infinity. The last step is to substitute the infinity. I forgot to write infinity here, a limit here, but you should. Now, if you put infinity, you get 0, right?
Yeah.
Is 0 less than 1? Yay! That means it is absolutely convergent. Remember the word absolutely. So first, what did we do? We used the alternating test. What's the alternating test? You have to show limit equals 0. You have to show that it is decreasing.
You have to show that an plus 1 is less than or equal to an.
Yes, which is being decreasing.
Oh, that's the limit part of it, right?
No, that's the decreasing part of it.
Where do we do that?
If you copy some of the terms, you're going to show decreasing.
Well, do you have to do that?
I would say, okay, here are the terms. This equal to, if you put a 1, what would it be?
1.
Would be 1. Plus, next term. Actually, not a plus.
-1, right? If you put in 1.
Yeah, you get -1. Okay, -1. It doesn't. -1. Then plus, the next term would be 2 squared over 2. That's a 2.
Okay.
Yes?
Yeah.
Minus. What's the next term? 9.
9 over 3 factorial.
9 over 3 factorial is 6. That's basically 3.5. I want to just simplify. 3 over 2. Is it? 1.5.
Yeah.
Then plus. What's the next term?
16.
4 squared 16 over, what was that be? 4 factorial?
Mhm.
4 factorial is 24?
Yeah.
Okay, can I simplify please at the same time?
Mhm.
Can we divide by 8?
2/3.
So 3, and the top is 2. Oops. 2. Then what? Minus what? Just one more.
25.
25 over 120?
Yeah.
Okay, can I divide by 5?
Yeah.
Yeah. 5 over 20.
That's a 5 over
24,
120 divided by 5 is how much? 24?
I think, yeah.
24. Okay. Is this decreasing? Don't look at the negative. Don't look at the positive. Just the values.
Yes.
But it's like increasing.
No, it's not. It's increasing first. It's
Yeah.
from 1. It become a 2. Then it decrease
And
to
after
1.5. Then it decrease.
Does that change anything, or?
No, it doesn't.
Okay.
No, it doesn't. If it's going to keep alternating up and down for the whole entire time, then yes, it makes a difference. Of course, I cannot tell. If it keep going up and down, I cannot tell. But what happened is this. The exponent is going to increase a lot slower than the factorial. The factorial end up with 120, right?
Mm.
The next number on top will be 6 squared, which is 36. But the bottom, instead of 120, will be 720.
Whoa.
So it's bigger, a lot bigger, right?
Yeah.
This one, the top grows from 25 to 36, while the bottom grows from 100 to 700. And if you keep going, you increase even more and more and more on the bottom, which means it is decreasing. It is. You can say it is decreasing starting from the third term. How's that?
I have a question.
Yes.
If it's inconclusive, if it goes up and down, is the alternating series test inconclusive, or does the series diverge?
That means I cannot tell.
Okay.
I cannot tell if this is convergent or divergent.
Alright.
But most probably what they give you has an answer.
And when would it be just divergent?
When is what divergent? This one?
No, when would the alternating series test give you like a
If
diverse.
if the limit to infinity is not a 0, let's say the limit to infinity was a 1 or 2 or half. If the limit is not a 0, it never converges,
Okay.
right? And if it's not decreasing all the time, it's not convergent. How about this? If I substitute this with sin x, what happened now?
Goes up and down.
Alternating all the time. We cannot control that. So this, I don't know what the answer is,
Or
right?
Mr.
Okay, I would like to continue a little bit. Hold on 1 second, please. I would like to continue a little bit. What do we say? We say number 2, which was the geometric. So if you get a series and asking you to add, find the sigma means add, right? Find the sum means add again. If it's geometric, test it if it's geometric or not. If it is, use the geometric formula, right? Next one was 5. 5 is this harmonic and P series. We said the P series will converge if
The P is
P greater than
1.
1. It diverges if
less than or
one or less. But by the way, 1 or less based on that P is greater than a 0. So P is always greater than a 0. If P is less than a 0, then it always diverges. If the exponent is negative, you're going to have to flip it and it become on top. And if the exponent is on top, no matter how small or big the exponent, it will increase all the time. Do you understand that? Like, let's say the exponent was a half, n to the half. That means we're adding, if it's a negative half, you're going to flip it. It become square root of n on top. That means square root of 1 plus square root of 2 plus square root of 3 plus square root of 4. That's increasing, not decreasing. While the one that we can add has to go all the way to 0 at the end. The limit, remember, of an should equal 0 at the end. So
what is that for?
P is always greater than 0. If you have to write limit for P is always greater than 0. And from 0 to 1, it diverge, including 1. Bigger than 1, it converge. Any question? Number 7 here, the alternating series test for conversions, which we just mentioned, right? Limit and decreasing all the time. If you don't write both, you are losing. 8, ratio test for conversions. The ratio test for conversions, you're going to have to test limit of a plus 1 over an, absolute value of that means no negatives. If there is a negative, eliminated. And if the answer is less than 1, we say converge. Answer bigger than 1, we say diverge. Equal to 1, we say inconclusive. Right? Last thing they want, find Taylor polynomial for a function. So if they give you a function asking you to write Taylor polynomial, you have to have Taylor polynomial in front of you. You get some derivatives of the function, you evaluate the derivatives, you put them in, you simplify your answer, and you're done. Nothing else is there. That's what they say it is.
But Mr. Ayad,
Yes, sir.
could we go over how to do the AN BN thing?
That's limit comparison.
Yeah, that one.
It's not there.
Oh, so we don't need to
Why
know.
would I want to go over it?
Okay.
It's not there. We don't need to know. Today we're concentrating on the test.
Got it.
You want to know anything at all for the sake of knowledge? I'm all for it, but not today.
Okay.
Like after we finish with that. Anyway, guys, I want you to relax. Everything is fine. I would really appreciate it if you just shoot an email telling me it was easy, it was hard, or whatever it is. and I'm giving you the rest of the week off. You have other APs that you need to take care of, and good luck.
Wait, I have one last question.
Yes,
The only limit test that we need is integral, alternating series, and ratio, right?
the ratio test. Yes.
Okay. All right. Thank you.
And I'm here at 4. If you have any question, I'm gonna open the Zoom again at 4. If you have a question, you can go on and ask the question. I'm doing that for people who have to go for the test, the physics test. Okay. Good
Mhm.
luck to you. And then I'm going to communicate with you by email and Teams. I'm gonna send you idea on what we're going to do after the AP exam, and it's going to be include very little kind of work, and we don't even have to meet again. All right.
Mhm.
So good luck to you guys. I hope I hear a lot of good news after the test.
Thank you.
Good luck and
Peace out.
have a good
Big
day.
man.